Assalamualaikum warahmatullahi wabarakatuh, madam. My name is Muhammad Narakim Umar, and as the Group D representative, I'll be presenting our programming simulation using Kill U Vision 5 in assembly language. Okay. In the first paragraph, we define all of the command that will be used in this programming code, and then on the second paragraph, we set the pencil 0 value to 0, which set any function to be used for every I/O pin. To set any function to be used for every I/O pin. And then we set the value of FIO0dir into 300 hexadecimal to set the pin 5 and pin 6 as our output. And moving on, we use FIO0mask function and set its value to FF7, FFC, FF hexadecimal to enable the read and write on pin 5, 6, and 15. Okay, in this paragraph is used to enable the power of ADC module, which is PCADC inside the P1 P. We enable the PCADC function inside the P1 P in this paragraph. And then in this paragraph, we set bit 21 on the AD0CR to high in order to let the ADC module to be operational. Okay, moving on. This paragraph is used to enable the clock and on ADC module and to set the clock frequency to 12.5 MHz, which is below 13 MHz. Which is 13 MHz is actually the maximum value of frequency that is allowed to be inserted into the embed LPC1768. Then moving on, we set the pin cell 0, 15 and 14 bits into 0 and 1 to enable the AD0.0 on pin cell 1, which is connected to pin 15. And then moving on, we use this paragraph AD0CR and to enable the input from pin 15 to be sampled for conversion of analog to digital using the cell register. And this paragraph is used to start our temperature measuring. We start with this LDR AD0CR. And then when the result is stored in AD0GDR, we load the digital conversion into R4 and we use LSR to push the result to LSB bit. And use this AND operation to isolate the result bit so we get the current temperature reading result in digital. And then we compare the result, the digital result which is stored in the AD0GDR to the we compare it with 250 hexadecimal, which is equal to 0.477 volts V in, which is also equal to 37.7 degrees Celsius, which means when the volts V in is equal to 0.477 volt, the surrounding temperature supposed to be 47.7 degrees Celsius. And then if the reading on the LM235 is greater than 47, the LED and buzzer will be turned on, which if the V in on the R7 is greater than OX250, the LED and buzzer will turn on, and if not, the LED and buzzer will be turned off. And this is the paragraph, the coding we use to set the LED and buzzer to be turned on. Use FIO0 pin, set the pin 5 and 6 be turned on. And this is the branch and delay we use to let the LED and buzzer to be turned on for a while. And this is the paragraph used to set the LED and buzzer to off or to low. And let's go to see the output simulation. Okay. let's see if let's say if our V in is equal to 0.47 volts, which is equal to 47.7 degrees Celsius. Okay. Okay, we can see that there is two output, which is buzzer and LED. In the buzzer and LED will turn on if the V in is equal to 0.477 volts, which is also means that the surrounding temperature is 47 degrees Celsius or greater than it. Okay. Let's say if the temperature is below 47.7 degrees Celsius, we can say, let's say this surrounding temperature is 30 degrees Celsius. Okay. Okay. As you can see, if I click on pin 5 and pin 6, there is no output. There is nothing here because the surrounding temperature is equal to 30 degrees Celsius. And therefore, we can say that our programming code is functioning. That's all from me. Thank you.